Hi folks, we're going to take a look at number 11 on page 301. So here they want us to find the exact solutions to this equation on the interval 0 to 2 pi. All right, so here our first goal is to isolate a trig ratio. And this one here is fairly easy because we can just do it using opposite operations. So I'll bring the 3 over 4 to the other side. So we end up with cos squared x equals positive 3 over 4. From here, I'm going to take the square root of both sides, remembering, of course, that I have to consider both the positive and negative square root of 3 over 4. And if I do a little simplifying, this can be simplified to root 3 over 2, which we recognize as being associated to a special angle. All right, and so this is why we're able to find exact solutions. So for this one here, I'm just going to use my knowledge of special triangles. So remembering that cosine is x over r, so clearly this is a pi over 6 or pi over 3 triangle, but it's the x component that's longer. So it's going to be the pi over 6 triangle. Okay, so this is where cosine would be equal to positive root 3 over 2, but it's also equal to positive root 3 over 2 in the fourth quadrant. And since I'm looking from 0 to 2 pi, I'm definitely working with positive angles. So we know this is going to be 11 pi over 6. Okay, and where is it negative root 3 over 2? Well, that's going to be in the second and third quadrants. So here we're going to have 5 pi over 6 and 7 pi over 6. So our final answer here is that x can be equal to pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6. All right, and that's a listing of all our answers. So just to recap here, step number 1 was to isolate our trig ratio. When you can do it via opposite operations, you certainly should. Here, I had to remember that when I take the square root of both sides of an equation, I have to consider that the positive and negative square root satisfy the equation. And then from there, I recognize this as a special, being related to a special angle, and was able to use my knowledge of those special angles to determine the solutions. All right, that's it for this one.